Hey, so I'm Patrick. I work on the Android team with Varsha, and I'm going to be talking about Klean Kotlin, which is using Kotlin in a clean architecture. So to do that, first I need to give kind of an overview of what clean architecture is. It was devised by Uncle Bob, who is Robert Martin, and he's the one who gave us solid principles. It's a way of separating concerns so that your business logic is completely separate from the rest of the stuff that makes up your application, be that like Android databases, UI frameworks, and specifically what it's aiming to do is make your business logic independent of frameworks, testable, independent of UI, independent of database, and independent of any external logic. So this is the canonical clean architecture diagram. It's kind of like an onion, where the stuff on the outside is the only thing that can be affected by any like external forces. The core of it, which is the enterprise business rules, should always be protected from anything that can change, like based on platform. So the way that you can think of that kind of is as like three different layers. The framework layer is the stuff that can change or is specific to a certain platform. Then you have sort of like an interface layer, which will adapt that so that the interactor, which is your business layer, won't have to be able to deal with those things as they come up. So if you were to make a call to the database based on like an on-click event, you'd have to go all the way down through that into your business logic layer and then all the way back up so that you could reach into the database. So also, this is Uncle Bob's diagram for what he thinks a clean architecture should look like. So I've gone and reformatted it a little bit like this, so it's a little bit easier to see. So the blue in this diagram would be the view. That stuff in the outer layer. The green would be the database and related classes, which would also be in the outer layer. And then the interactor and the stuff that it's interacting with would be the business logic layer. So it keeps it all nice and kind of like sorted out, separation of concerns. So that brings us to our current architecture, which is based off of clean, but it's not exactly clean. We wanted to go kind of in the same direction as Viper for iOS. So we split it out into 6 main classes, which are that 4 in the middle vertically, plus router and tracker. So I'm going to go into those a little bit more in detail. The stuff on the left-hand side is to do with one of our libraries, BritKit, which was developed in-house. It sort of abstracts smaller layouts that can be included inside of a main layout. And it's all to do with recycler views. So check that out if you have a chance. Wrong way. Cool. So at the top of the hierarchy is the view. It's usually a fragment, and it does all the Android-specific stuff so that Android doesn't permeate down into the other layers. It has a reference to the presenter, and previously it had a reference to the router, but we've recently just changed that. So now when we're trying to switch different screens, we would have to go down into the interactor first. Then the interactor would do the routing. The presenter is in charge of just moving things around inside of the view. So what that means for us is it'll rearrange where bricks are on the screen, and that is just to do with our BritKit library. It has a reference to the interactor in the view so that the interactor can tell the view what to do without actually having to access the view directly. The interactor is all the business logic. It operates on data models which get generated from network requests. It does things with UI events. It operates pretty functionally, so so that we don't have like other business logic elsewhere in the application. The repository is kind of like our screen between the database and the network layer. So we can just ask the repository to give us data, and then it will decide whether it wants to go into the database or across the network. And it'll create data models which get filtered into the interactor and then all the way up to the view. So again, we don't have to worry about like the details there. We can just pass things through and it works. The router, kind of self-explanatory. It'll route you to a different page. So usually it'll have reference to the current fragment and the current activity so that we can move around that way. And the tracker is the most optional one of these. It's literally just for tracking events because they're kind of like no-ops. You don't want to have to worry about them when you're doing your actual business logic. So that brings us to applying Kotlin to our Klean architecture. Nullability in Android is kind of unavoidable, and in a lot of other systems situations as well, due to the way the framework is set up. So for instance, on rotation, you're going to lose the reference to your fragment inside of your presenter. That's just something that's going to happen. So it's going to get filled with a null. Kotlin allows us to limit that so that we don't have to remember each time. Kotlin will do the remembering for us. And the most important takeaway from Klean in general is that the inner layers should always be protected from outside changes. So the way that we limit that nullability is through our data models. They're created through repositories, and then they get fed up through the rest of the layers to the view. And as part of converting to Kotlin, we are converting a lot of data models over to data classes for a variety of reasons. They can easily be tested for equality because they have an equals method. Non-nullability can be guaranteed for each field in the data model, so the repository will act kind of like a filter, and it'll just fill in default values where necessary. ToString is useful for debugging. Getter setter syntax is nice and concise, and you'll never forget to actually make a getter or a setter, because Kotlin will just take care of that for you again. And final classes encourage composition over inheritance, so you don't have like weird hierarchies between different data models. Also building off of that, apply is really useful for making really complex data models. So this is just like a toy example, but you can already see like how it would be useful. You can see the structure of the data model just by looking at that. And if you have multiple apply chains, you can make objects as complex as you need. Yeah, repositories get used as a filter. Their main job is to create data models based on whatever data we have. So it'll switch between the database and the network and just pass those up the stack. And one other use that we found is for the presenter, making sure that we always check that the view cannot be set to null. So one of our most common null pointer exceptions is just on rotation, forgetting to check if the view is actually there. This will fix that for us. And last but not least, interactors allow for a lot more functional programming. They shouldn't really have to deal with the state that's like surrounding the rest of the application. They should just be able to function to work on the use case of things. So under there, right there, is a good definition of functional programming, because I know Java developers in particular focus on object-oriented. Functional programming languages are good when you have a fixed set of things and you primarily add new operations upon them when you add new code. Object-oriented programming is pretty much the opposite when you have a fixed set of operations and a variety of things. So with using Kotlin in a functional way, it lets you be a lot more descriptive about your use cases. The thing on the right over here is one of the examples I thought was really good from Kotlin Conf last year, where they used infix notation and lambdas with receivers to make it really clear like what's going on in this heist. Yeah, the flexibility of Kotlin lets us use Klean architecture in a more expressive way, and I think that's really awesome. Do you guys have any questions? Well, that brings us to Kotlin native.